Imagine drifting in the Antarctic Ocean and making the mistake of looking down. You're expecting to see tiny fish and drifting plankton. Instead, you see creatures so large, they feel like they're from another planet. The Antarctic Ocean looks empty from the surface, but beneath the ice lies one of the strangest biological experiments Earth has ever produced. This is a place where spiders grow wider than dogs, jellyfish stretch longer than whales, and animals that look completely ordinary elsewhere become unnervingly massive. This phenomenon is real, well documented, and known as polar gigantism. At first glance, it doesn't make sense. Antarctica is brutally cold, dark for much of the year, and food can be scarce. Logic suggests animals here should shrink to conserve energy. But evolution chose the opposite path. In the coldest oceans on Earth, many animals became supersized versions of themselves, creating an ecosystem filled with giants. To understand why this happens, it helps to start with one of the most extreme examples ever discovered: the colossal squid. Many people assume colossal squids are simply a product of the deep sea, but that's only part of the story. Colossal squids live almost exclusively in the southern ocean surrounding Antarctica, swimming in water that hovers around 0 degrees Celsius. Because of its salt content, the water doesn't freeze, but it remains unimaginably cold. Colossal squids belong to a group known as glass squids, named for their transparent bodies. Yet colossal squids are anything but transparent. Instead of delicate, see-through tissue, they have thick, muscular flesh. This change wasn't random. In near-freezing water, transparency offers little advantage. Insulation, on the other hand, is everything. Their reddish coloration absorbs light rather than reflecting it, making them nearly invisible in a world where most illumination comes from bioluminescent prey. When you're that large, escape isn't the priority anymore. Stealth becomes about approaching, not fleeing. Still, none of this explains why colossal squids grew so massive in the first place. For animals that breathe directly from water, oxygen is a limiting factor. In warmer oceans, large bodies simply can't get enough oxygen to support massive cell counts. But in Antarctic waters, oxygen is everywhere. That biological ceiling disappears. Over millions of years, this abundance allowed animals to grow larger without suffocating. Larger bodies also retain heat better and store more energy, making them even more efficient in cold environments. Evolution didn't just allow gigantism eat favored Italiano. Colossal squids also experience a second influence: depth. While they aren't purely deep-sea giants, they live deeper than their relatives. This makes them a rare example of double gigantism, shaped by both cold polar waters and deep ocean pressure. This combination is why colossal squids are the heaviest invertebrates ever recorded, even outweighing giant squids by a wide margin. But squids alone don't prove a pattern. The true evidence of polar gigantism appears when you look at creatures that are normally tiny. Sea spiders are a perfect example. In tropical reefs, sea spiders are barely noticeable, often just a couple of centimeters across. They look like fragile curiosities rather than threats. In Antarctic waters, the same family of animals grows to shocking proportions. Some Antarctic sea spiders span more than 2 feet from leg to leg. While blue whales dominate by mass, lion's mane jellyfish can stretch longer from tentacle tip to tentacle tip. Compared to related jellyfish species in warm water, the difference is dramatic. Warm water jellies remain relatively small. Cold water conditions remove the constraints that kept them in check. Oxygen abundance is only part of the story. Cold temperatures also slow metabolism. In warm environments, large bodies burn enormous amounts of energy just to function. In cold water, chemical reactions slow down. Large animals burn less energy per unit of mass. Bigger bodies become efficient rather than costly. The Antarctic Ocean is also remarkably stable. Temperatures fluctuate very little. Pressure remains constant. Apex predators are relatively rare. There's no need for speed, agility, or rapid reproduction. Animals can afford to grow slowly, live long lives, and invest in size rather than flexibility. Polar gigantism applies primarily to cold-blooded animals that rely on environmental temperatures and extract oxygen directly from water. Warm-blooded animals operate under completely different rules. They must constantly burn energy to stay warm. As body size increases, so do calorie demands. Warm-blooded animals do follow a separate pattern known as Bergmann's rule. In colder climates, they tend to be larger than their tropical relatives, because bigger bodies lose heat more slowly. That's why polar bears dwarf other bear species, and emperor penguins are much larger than tropical birds. But there's a limit. Beyond a certain point, the energy cost becomes unsustainable. Even the smallest life forms aren't immune to polar gigantism. Antarctic copepods, tiny crustaceans that make up plankton, can grow nearly 10 times heavier than their tropical counterparts. While still small by human standards, they are enormous within their ecological role. Not every species followed this path. In rare cases, the opposite occurred. Some Antarctic fish exhibit polar dwarfism, evolving smaller bodies to mature faster and reproduce during short windows of food availability. When resources are unpredictable, speed can matter more than size. One of the strangest consequences of Antarctic life is how slowly evolution itself moves. Cold temperatures slow metabolism, growth, and reproduction. Some species take decades to reach maturity. As a result, evolutionary change happens at a crawl. Many Antarctic animals are living fossils, nearly unchanged for tens of millions of years. This stability has allowed polar gigantism to persist, but it also creates fragility. These animals are perfectly adapted to a world that doesn't change. As ocean temperatures rise, oxygen levels drop. Metabolism speeds up. Bodies built for cold efficiency become liabilities. Evidence already suggests that the maximum sizes of some Antarctic species are shrinking in warming waters. The giants of the frozen deep are running out of space to exist. No verified human deaths have ever been caused by colossal squids. These creatures are not monsters. They are masterpieces of evolution, shaped by cold, time, and stability. Freeze the ocean, and life doesn't disappear. It grows enormous. Thanks for watching. If you enjoyed this journey into the bizarre world of Antarctic giants, don't forget to like and subscribe for more deep dives into our planet's strangest secrets.